Today we will start with problems based on acid-base reactions. We will attempt a problem from the topic neutralization reactions in this video, which contains mainly three types of problems. Let us begin with the very first type today, which is calculating the amount of base needed to neutralize an acid. In this problem, we need to find the volume of barium hydroxide required to neutralize a solution of nitric acid. Here we are provided with the concentration of barium hydroxide and both volume and concentration of nitric acid. The very first and an important step in these type of problems is to write the correct balanced chemical reaction. In order to do that, we first need to know about the nature of reactants, which in turn will help us to write the products. The given reactants are nitric acid and barium hydroxide, which are acid and base respectively. And we know that when acid and base react, they lead to the formation of salt and water. Before proceeding to the next step, please double check that the chemical reaction is well balanced. The next step is to unpack the provided data and write it underneath the chemical reaction. I'm writing this data underneath the chemical reaction just for my convenience. You are most welcome to choose your own writing structure for this step. I'll use lowercase c for the concentration and lowercase v for the volume throughout. The third step is about calculating the number of moles of the species for which both concentration and volume are given, which is nitric acid in this case. If you can recall the relationship between concentration, volume, and number of moles, it is C equals N over V. We can rearrange this equation to make number of moles as subject of the equation. Please be aware that the volume entered in this equation is in liters. Now we just plug in concentration and volume of nitric acid from the data above and multiply them to get to the number of moles of nitric acid, which comes out to be equal to 0.03 moles. Once we calculate the number of moles of nitric acid, we can easily figure out the number of moles of barium hydroxide using the mole ratio of the reactants. From the balanced chemical reaction, we notice that the number of moles of barium hydroxide are half of that of number of moles of nitric acid. Let's just plug in the value of the number of moles of nitric acid calculated previously to get to the number of moles of barium hydroxide. For barium hydroxide, we now have the number of moles and concentration, and we need to calculate the volume. We can calculate easily just by rearranging the same formula to make the subject V this time. The formula for V turns out to be equal to N over C. Now we can simply plug in all the numbers and calculate the volume. Dividing number of moles with concentration will give us volume in liters. We can convert it to milliliters very easily just by multiplying with 1000 or 10 raised to the power of 3. The volume in this case comes out to be equal to 50 milliliters, which is the final answer to this problem.